Welcome to the second generation of Intel's Core i-series processors. So we've got Intel Core i3s, Core i5s, and Core i7s, but these are not, it hasn't been that long. These are not your older brothers, Core i3s, i5s, and i7s. This is based on the new Intel codename Sandy Bridge architecture, which means we have new motherboards, a new socket, and much improved performance over the older Core i3, i5s, and i7s. So they've changed the branding a little bit. They all start with a 2. Instead of being a Core i3 530, for example, it would be a 2.5 something something. Okay, so that's how you can tell it is a second-gen Core series processor. For example, the one we're going to be using for our overclocking guide today is the Core i7 2600K. So it's a Core i7, which means it's a fully hyper-threading enabled quad-core chip. All right, then you've got a 2, which means it's a second generation. It is 600, so that would indicate clock speed, basically. And then you have a K suffix at the end, which means it is unlocked. And we're going to get into a little bit more detail about what unlocked means in just a moment. But I want to give you guys some clarification about the changes first. We still have support for Crossfire and SLI on most 1155, that is the new socket, LGA1155 motherboards, as long as you do have dual physical PCI Express 16X slots, although you will want to look into the individual board that you're shopping for. We do still have support for dual channel DDR3, but the main changes, like I said before, are with the socket. We also have one other change, chipset-wise, and that is that Intel has added support for 2 SATA 6 gigabit per second ports off of the chipset. So many of the higher end boards are coming with 4 SATA 3 gigabit per second ports, 2 SATA 6 gigabit per second ports off the Intel chipset, and then 2 additional ones off of a third-party chipset. Okay, so as with our previous overclocking guides, we're going to do a bit of a shopping list for you guys. So the first 2 things are pretty much a no-brainer. You should already know this. If you're going to be doing overclocking, you want to get a nice high-quality cooler. So something like a big tower air cooler, or even water cooling if you want to go a little more extreme, something like a Corsair H70. And then for power supply, you want to pick something that's a good quality, high-efficiency power supply. Something from Corsair's AX series would be a great choice. So those are sort of my 2 recommendations off the top of my head for those. And then let's get into the 2 parts that have changed over the last generation of products. So I'm going to start by talking about this one right here. If you are going to be overclocking your system, this is a gaming system, forget about this. This uses the H67 chipset. So while it supports all of the Intel next generation Core i-series processors, it does not support overclocking. You cannot overclock using the motherboard anymore. You have to use the multiplier on the CPU, and H67 does not support the multiplier changing feature. So not good for overclocking. However, if you want to build a media PC, or it's just a lightweight office machine, and you want to use the onboard graphics that are present on every new generation Core i-series processor, then go ahead, grab an H67, because P67, the performance series of this chipset, does not support onboard video. Every P67 motherboard supports the same processors as the H67 boards, but there will be no onboard video slots on the back of the board, so you must use discrete graphics. Now, the P67 also supports splitting its single PCI Express 16X slot into dual 8X slots, which is going to give you Crossfire support, and on motherboards that have the certification, NVIDIA SLI support. So P67 supports a couple of different things, but before it all kind of ties into the K-series processor. So Intel has a few different kinds of processors on this new LGA1155 socket. They have regular processors, which do not support turbo, and I've explained turbo in the past, and they do not support completely unlocked multipliers, which are the K-series. So a non-turbo, non-unlocked chip, nothing. No overclocking. You might be able to overclock maybe 5% if you've got a board that supports it, but that's it. The new chips do not support motherboard overclocking, period. Okay? So if you have a turbo chip on the other hand, so something like a Core i5 2500 non-K, then you can overclock up to 4 speed bins past the maximum turbo mode. Now, remember that turbo supports turning it up even higher if you're running fewer cores. So you have a maximum of 4 multiplier increase if you're running a single-threaded app, and then you can actually go 4 above that. So a turbo processor is a semi-unlocked processor. Now with the K-series processors, you don't have to play around with turbo, you don't have to really care about anything except your CPU voltage and your multiplier. You just change the multiplier and that's it. You increase the frequency of your CPU. So all of those overclocking modes are supported by P67 motherboards. So in summary, if you haven't been listening, which I don't blame you because that was really long, if you want to overclock, you want a P67 motherboard and a K-series unlocked processor. Sorry. 2 more things I didn't mention in that last shot that I probably should have are that you can still adjust the base clock. Like I said, you can probably get about 5% out of it, but when you turn up the base clock, you're turning up not only your CPU, you're turning up that integrated graphics core, you're turning up your PCI Express bus, all kinds of nasty stuff. You can corrupt the data that's running on your hard drives. Basically don't touch it would be my recommendation. And when you're choosing RAM, go with a high quality low voltage kit. Anything certified for Core i7, Core i5, and Core i3 last generation stuff, that means it's going to be running at 1.65 volts or lower, and that'll be fine for the new generation chips as well. So I just want to show you guys what I was able to achieve with my test platform here, which is using the P67A GD65, as well as a Core i7-2600K fully unlocked processor. I have not been using Intel Turbo Boost, so that means that whatever speed I'm running at is the speed I'm running at. It's not going to turn down if I have a lower stress on it. It's not going to turn up if I'm running a single-threaded app. I could play around with it and tune it more and adjust those parameters, but I have opted to go with just a straight overclock on this particular chip. So with only about 1.4 volts of VCore, that is volts to the CPU, I was able to get 4.7 gigahertz out of this chip. This is a 3.4 gigahertz stock processor. So that is an outstanding overclock. Now my temperatures are quite high, but for the sake of having no noisy fans blowing into the microphone here, I've actually gone ahead and installed a silent fan on my cooler. Running a more high performance fan, my load temperatures didn't go over about 75 degrees last night when I was tinkering around with this particular setup. So I'm going to show you guys how to do this in just a minute. It's really, really easy. Alright guys, so I'm pressing delete to get into the BIOS here, and check this out. This is not your older brother's BIOS either. This is a unified EFI BIOS, which means we have full support for a graphical UI. Alright, we have full support for the mouse, so you can see I can actually move my pointer around with the mouse. Apparently there's also games. I haven't tried out this particular feature because I'm mostly concerned with this OC button right here. So I'll show you what options we did need to adjust on the P67A GD65 in order to get our overclock. We've left our CPU base frequency completely stock. We adjusted the CPU ratio, which if I just double click, I can use the slider to select whatever ratio I want. So we're at 47. The math is really easy on this platform because the base clock is 100. So whatever multiplier you have times 100, that's your end result frequency. So 47 times 100 is 4.7 gigahertz. That simple. I've adjusted my RAM frequency to DDR3 1600 megahertz. I went in and adjusted my timings by double clicking. Okay, you right click to go back, which is pretty convenient compared to using the keyboard. I've adjusted for low V-droop. And what low V-droop means is that under load, it does not allow the voltage to the CPU to sag. Now, high V-droop, which is the default configuration in this BIOS, is sort of recommended by Intel, but I was able to get better stability with low V-droop. My temperatures were still acceptable with my high-performance fan, so I left it on low V-droop. You got to experiment and find out what works better for you. For the DRAM voltage, I've put it at as close to 1.65 volts as I can get without going over, and pretty much everything else you shouldn't touch. Now CPU I/O, you can try adjusting that one to get a little bit more performance, especially if you're running 4 memory modules, which is more stressful. But other than that, don't touch anything else because it is not beneficial to overclocking. That is pretty much everything we need. We've also got a couple other useful features in here, such as the overclocking profile. Oops, I clicked the wrong thing. Such as the overclocking profiles, which you can use to save different settings. You can name them whatever you want. So that's a pretty useful thing. So I saved my finalized overclock in there. And other than that, that's really all there is to it. That was it. That's the overclocking guide. So before we wrap things up, let's talk a little bit about the due diligence that you have to do with any overclock to ensure that it is stable. I'm using Prime 95 and I'm going to show you guys the settings that I used in order to ensure that my 4.7 gigahertz overclock was stable. So I'm going to stop it right now, but I'm running 8 threads. So if you have a hyper-threaded quad core, you're going to run 8 threads. If you have a regular quad core, you're going to run 4. And I'm using small FFTs to give maximum stress to the CPU. I can set how many threads to run, in my case 8, and I click OK. I walk away, and if I'm going to use this as a day-to-day production machine, it better run for 24 to 48 hours without any errors. If you get any errors, you need to back off your overclock or turn up your voltage in order to make sure that you are running stable. Now, when it comes to turning up your voltage, remember guys, more voltage means more heat. So you can see right here, using RealTemp GT, I'm getting temperatures up to about 85 degrees on my CPU. Like I said, I'd consider that outside of the comfort zone. I'd say anywhere above about 70 to 75 degrees is probably too high, but I had to put on a quiet fan for my microphone, so with a performance fan on there, I was getting acceptable temperatures, so that is why I settled on this overclock. So how to pick a motherboard? Basically, it's going to come down to the features that you need these days, and it's also going to come down to the overall layout. I mean, there's the aesthetic, there's things like, for example, the slot layout. So this is a great example to look at because I think the P67A UD4 has an outstanding slot layout. You can install 2 dual slot graphics cards in these 2 slots. You're left with 2 PCIe 1X slots for additional expansion, 1 PCI legacy slot for maybe a sound card or something like that. So that's one of the ways you can pick. You can also pick based on other features, like how many USB 3.0 ports. Why don't we talk a little bit about some of the differentiating features on all of these different boards I have in front of me. So Gigabyte has their ultra durable 3 concept, which means they have double the thickness in the copper PCB. They have their on-off charge feature, which allows you to charge your devices even when the system's not powered on, which is great. You turn your computer off for the night, you leave your iPhone charging on it, you win, right? You save power, all of that is good stuff. They also have their USB 3X power feature, which allows you to deliver 3 times the amount of current through a single USB port as you can on a more standard motherboard. Now moving on to ASUS, they've actually completely revamped the way they do their VRM, so their power delivery. Remember, power delivery is pretty much one of the most important features for overclocking on a P67A motherboard because you're just using the multiplier to turn up the frequency and then you're increasing the voltage to the chip. So they're using on this particular one a 16 plus 2 phase fully digital VRM solution. They also have a couple of other interesting features. This guy right here supports Bluetooth, for example, and also includes a front panel USB 3.5-inch bay. So there's cool little adders that the motherboard guys can now throw into their motherboards that differentiate them. MSI is using now their 2nd generation. MSI has been using their digital VRM solution for a couple generations now, so they're calling it Military Class 2, and that is allowing you to have up to, they're saying, a 10 years minimum lifetime on the VRM components on their boards. They've also upgraded their OC Genie to version 2, which supports CPU overclocking on P67 with K-series, and then actually supports overclocking the integrated GPU on H67 boards. So that's one of the cool things that they've implemented. ASUS and MSI have also both implemented the graphical UI in the BIOS. So that's a really neat thing there as well. So thank you for checking out our overclocking guide for the P67 LGA1155 platform. Don't forget to subscribe to NCIX Tech Tips. And I do have a question for you guys at the end of this episode. Based on that we can achieve these overclocks of 4.5 to even, I've seen guys hitting up to 4.8, 4.9 gigahertz on air with these chips, And based on the fact that you're looking at a 5 to 10% performance increase clock for clock over last generation chips, are you considering an upgrade to the P67 platform, and what configuration would you use?